Once again, welcome back to our education hub. Well, once again, I request you to please subscribe and press the bell icon. Today, we'll discuss something more about the electrostatics. Before going to the electrostatics, just I will recapitulate the yesterday's class. Yesterday, we have discussed about the electrostatics and electricity and the history or the background behind the electricity. So today, first of all, we'll point out some of the points, which points we will discuss today, and detailed discussion regarding this we'll discuss later. First of all, the today's topic, first topic is about the charge. Second topic is that about the properties of charge. The next topic is Coulomb's law, and the last topic today's class is electric field intensity. Before knowing about the electric field intensity, we shall discuss about the electric field also. We all know in the last class we have discussed about what is the charge, what is the nature of the charge. We know the charge is the basic property of a material. In the charge, we know the negative and positive, the negative for the electron and positive for the proton. That does not imply the negative charge means lesser than the positive charge. Only it indicates the nature. Means the charge is completely a conventional charge. Now, we know the charge, the value of a charge of an electron or proton is 1.60218 into 10 to the power minus 19 Coulomb. Let's discuss about some of the properties of the charges. There are some properties. First is it is a scalar quantity. Second is the discrete nature or conservation of charges. And third property is that additive nature of the charge. Fourth property is that charge is quantized. Discrete nature or quantization of charge. And next is the conservation of charge. And fifth is the invariance of charge. We shall discuss everyone by point by point. And next we will discuss about the electric field and the electric field intensity. Now first of all we will discuss about the charge. We have known already charge is the basic property of any element, and charge is the only cause to create the repulsion or attraction force between the charged particles. The repulsion force for the similar charges and attraction for the opposite charges. Now the question arises, why the similar charges are repulsing with each other and why the dissimilar charges are attracting with each other. For the sake of this, we will discuss a little bit by a simple example. For this one, I will take an example. I will take two pendulums and they are hanged by a fixed surface. When these two pendulums are touched with different objects, and what is these objects? They are the charged objects. First of all, I will take a amber which is already rubbed with the woolen cloth, and I will take next the glass rod which is already rubbed with the silk or silken cloth. What I will do? First of all, I will touch this charged ember. Why this is called the charged ember? Because when this ember is rubbed with the woolen cloth, it gets charged. And when this ember is touched with this and this, then what will happen? This will automatically separate or repel with each other. Why? Because when we are touching this ember with these two pendulums, what will happen? These two will gain the same charges or the same positive charge. Then what? Sorry. When these two pendulums are touched with the ember, those two will get the negative charges, and due to which they will be repelled with each other. If you do the same experiment with a glass rod, and if you toss these two pendulums with the same glass rod, then we will understand these two again repel with each other. Means that we can conclude that when the two similar charges are there, then they will repel with each other. But what we will do now we will rub the ember with the woolen cloth, and we will toss with the pendulum A with the ember and pendulum B with the glass rod. As we know, the ember is negatively charged and glass rod is positively charged. Then what will happen? They will attract with each other. Means we can understand that the opposite charges are attracted with each other and similar charges are repelling with each other. And from this one we can conclude that the opposite charges attract with each other and second, similar charges, the same charges repel with each other. Before going to the further, yesterday in the class, some of the students were asked about the question, what is the electrostatics? The electrostatics is the branch of physics which deals with the study of charges at rest condition. That means what? Those we are studying is the charges about the rest condition. As we know, the ember and glass rod are charged by the rest charges. How they are charged? Just by taking in one ember. Let's take this is an ember and this is a woolen cloth. When these two are rubbing with each other, generally what happens? Let's take this is an atom of an ember. Here the electrons and protons are distributed in such a way they have equal number of electrons and protons. Then in the same way, if you take an atom of an woolen cloth, in the same case there also electrons and protons are distributed in such a way there are equal numbers of electrons and protons. Means they are electrically neutral. But when the case of when both are rubbing with each other, then what will happen? Some of the negative charges from woolen cloth will enter into the ember. Then what will happen? The number of negative charges in the ember is more than the positive charges. Then what will happen? This will becomes negatively charged body. Here what will happen? The number of negative charges is less than the number of positive charges. Then what will happen? This is positively charged body. And hence these two becomes the charged bodies. Means here only those charges which are in rest condition, they are only transformed. That's why these as we are studying these things about the charges in rest condition, that's why they are all called the electrostatics. And today we discuss when these charged bodies, when these two charged bodies are, how they are attracting a neutral objects. Today we will discuss how these charged bodies are attracting the neutral bodies. See, let's take the example of an amber. As we know, already discussed, here the number of negative charges is more than the positive charges. Means it simply indicates that this is a negative charge body. Here, let's take the number of negative charges are more than the positive charges. Here in this case, as this amber is a negatively charged body, we are taking some peppers. Here also, this is also electrically neutral body. Then what will happen when we are taking this negatively charged body to the some of the peppers? They are the electrically neutral. What will happen? As it is a negatively charged body, it will attract the positive charges. These positive charges will come forward at the edges of the pepper. Then what will happen? As it attracts the positive charge, that's why this pepper will attract here. And this type of charge is called the induction. Okay, means it is here the electricity is induced. That means what? It is induction charge. In the same way, there are three different types of charges. The charges were created. First is the charging by friction, charging by conduction, and charging by induction. Those three things we will discuss now. First, charging by friction. Remember, these three types of charging is only for the charges in rest condition and not for the motion condition. Charging by conduction, and third is the charging by induction. Friction. We all know the friction. What is the friction? In the friction, what will happen? The two bodies or the two surface of the bodies are rubbed with each other. In the same way, in the amber and woolen rub, these two are rubbing with each other. When these two objects or the neutral objects are rubbing with each other, though the charges will transfer from one body to the another body. Means those charges, the positive charges or negative charges, will transfer from one surface to the other surface. Then what will happen? The number of number of positive charges or the number of negative charges will difference, or the number of positive charges and the number of negative charges in each surface will differ. Then what will happen? If in a surface the number of negative charges are transferring, means here the negative charges will be more than the positive charges. This indicates that it is negatively charged body. In the same way, from where the negative charges were coming, means that the number of negative charges are less than the number of positive charges. That means what? The number of positive charges is more than the number of negative charges. It clearly indicates that this is a positively charged body. Means in such way, by the rubbing or by the friction, the charge will be, or the body will be charged. That's why this is called the charging by friction. And secondly, we will see what is charging by conduction. Conduction, we already know. The conduction means if any surface will touch with another surface. In the pendulum experiment, we have discussed that the charged body is touched with another neutral body. Then what will happen? The number of charges will be transferred. That does not imply how many number of charges are more. Those all the charges will go. As we know, if we have seen in the balanced, if you take the two tubes, and the water level is different, then if you connect one pipe, then the water will flow until the two levels are equal. In same way, when we'll take the charged body to a neutral body, the charges will flow until the two charges are same. That means what? Some of the charges will go to the another neutral body. Means in the neutral body becomes a charged body, and charged body still there is a charged body. That means what? By the conduction also we get the charged bodies. In the same way, what is by the charging by induction? I already said you what is the charging by induction. Again I will recall to you. If you take a charged body and if you take another neutral body, and we do not have to touch with each other, only if you keep another neutral body here, then the charges in the neutral body or the opposite charges, as it is a negatively charged body, the positive charges will come to the surface or the edges of the surface. Then what will happen? Here it will become a positively charged and the negative charges will be redistributed here. The negative charges will be redistributed here. If you want to take the earthing position, or if you look up this one, all the negative charges will go in this direction. Then what will happen? If you will be remove this earthing, then it is completely a positively charged body. This is called the charging by induction. In these three processes, we can any objects we can be charging. Now the question you might feel, what is these three charges? What is the benefit of these three charges? Yeah, there is some applications there. What is the three applications? You have seen when in the painting, generally day to day the painting is done by spraying. When this spraying was happening, that time what will happen? The nostrils, the openings, which is when all the particles will come out of this nostril, these all are equally charged. Then what will happen? As they are the same charges, they will repel with each other and they will spray evenly. In the same way, if you see at the time of any industries, there is just too much of pollutions will come out. In the chimney, they will put one positively charged filter. In the same way, they will put above the positive charged filter, they will put one small metal which is negatively charged. When this dust with the pollution will come outside by the chimney, as it will enter to the positively charged surface, it will all the particles and including the foam, or the simply we can say the like the air, it is the dust and the pollution all will be positively charged, and when it will passes through this filter and all gets the positive charge, but when it will reach to the metal surface as it is negatively charged, then what will happen? All the positively charged dust particles will attach to this metal and all the pollutant will go outside. In same way, there are some applications for which this charging is most important. Next, we will discuss about the properties. What are the properties? Just as say you, first property is this is scalar quantity. As we know, charge will move in a particular direction, but it has a scalar property. Why? Because it has only magnitude, there is no direction. That's why charge is a scalar quantity. Second is the quantized nature or discrete nature. What is quantized nature or discrete nature of the charge? See, we know there is two type of charges. One is positive charge and negative charge. And in a material, there are three type of particles. One is electron, proton, and neutron. Let us take to consider this. There are only two types of charges are there, and these charges are the observable properties of a material. Then what will happen? All the total charge of a body is sum of the, if you take the N1 is the number of electrons and N1 into E plus N2 is the number of protons N2 into plus A is the total charge. Then what will happen? This will be N2 minus N1 into E. This is the total charge of any metal. But it has seen that there is no such case. Means there is some of the charges which have the charging properties, or the sum of the particles which has the charging properties. That's why every metal has a multiple of charge E. Means there is no continuous charge, or there is a package of charges, or the quantity of charge is the multiple of E. That's why this is a quantized or discrete nature of the charge. And third, we will discuss the conservation of charge. We know in an isolated system, the net charge is constant. That means what? It is easy to create a charged particle or destroy a charged particle, but it is not possible to destroy the charge. That means what? The net charge is always zero. That means what? In a beta decay, so what will happen? The neutron becomes a proton, where the electrons will be released. That means what? Here the charged particles are creating, but the total charge becomes zero. Means the net charge becomes zero. Let us take the example in the uranium case. Here uranium 90 to 238 in radioactivity. What will happen? Here thorium 90 to 34 will release. In addition to this, the alpha particle will release. Here what happens? In this decay process, the total number of, here you can see 92 equal to 90 plus 2. Means here this is the 90 plus 2. This is the number of 2 electrons. Here 90 electrons is 92 electrons. That means what? The total amount of charges is, or the net charges is constant in a conservative body. That's why the charge is always a conservative. It always obeys the conservation property. Next is the additive nature of the charge. Additive nature. What is the additive nature? If you see in an extended body, the sum of all the charges is constant for that body. Means if you take this is an extended body. Here some charges are there in a different position. See, these charges can be added with each other. If there will be a negative charge or the electrons, you can add the minus, and if it is the positive charge, you can use the plus symbol. That means what? All the charges will be added with each other. And next is the last point is the invariance of charge. Fifth is the invariance of charge. That means what? If you change that, you already know what is the frame of reference. If you change the charge from one frame to another frame of reference, there is no change in the charge. That means what? If you change the frame of reference, there is no change in the value of the charge. That's why it will be invariant. Means what? It will not vary when it will be changed from the one frame of reference to the another frame of reference. Now we discuss about the Coulomb's law. The third property or the third topic for today's discussion is the Coulomb's law. Coulomb's law deals only with the charges to the rest condition. And remember, not only Coulomb, with the Coulomb, some other scientists also worked for this one. And he said that if you take the two charges, one charge is the Q1, another charge is the Q2. And these two charges, as these two charges are there, surely there is an electric force is there. Because I already said you in the introduction class, if the two charges are there, means these two charges are applying an external force or the extra force. This force is called the electric force, as the charges are in rest condition, that's why this is called the electrostatic force. Electrostatic force. Or simply I will write as the F. This electrostatic force of is there may be attraction or may be repulsion. If both are the positive, there will be repulsion. If both are the negative, then surely it will be repulsion. If one is the negative, another one is the positive, or one is positive, another one is negative, there will be surely a attraction. This electrostatic force of attraction or repulsion is directly proportional to the product of their charges, means Q1 into Q2, and inversely proportional to the square of the distance between the two charges. Let's take the distance is the r, then this will be 1 by r square. Again, I am repeating this one. The electrostatic force of attraction or repulsion between these two charges is directly proportional to the product of the two charges and inversely proportional to the square of the distance between the two charges. Means I can write as this one, F proportional to Q1 Q2 by R square. Understand? Hence, this F equal to K into Q1 Q2 by R square. What is K here? All you know. Whenever there is a proportionality, we shall use the proportionality constant. Means here K is the constant of proportionality. Constant of proportionality. And understand one thing, this is an experimental law. That means what? It is the value of this one is experimental. That's why as F is the constant value and Q1 and Q2 and R all are the constant values. That's why Q also have the some value. And from the experiment it has known that K equal to 8.98755 into 10 to power 9 Newton meter square per Coulomb square. Understand? What is the value of K? 8.98755 into 10 to power 9 Newton meter square per Coulomb square. And from this one, from the experiment also it is known that K equal to 1 by 4 pi epsilon naught. This epsilon naught is known as the permittivity of free space. And remember, this is the SI value we are using, not CGS value. That's why K is the 1 by 4 pi epsilon naught is only used for the SI value. That's why we can use that K as the 1 by 4 pi epsilon naught. Let me erase. F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Understood? And in the vector form, we can write this one F vector equal to 1 by 4 pi epsilon naught Q1 Q2 R vector by R cube. How we can write is the in vector form. Let's take it is the point A. This is the point B. Here Q1 charge is there. Here Q2 charge is there. Here this is the distance R and the force will be in this direction. If there will be in this direction, that's why this is the R vector. Okay, because it is a central force. Why it is a central force? It is acts along the line joining between the two charges. That's why it is a central force. And remember, this will apply for the point charges. This Coulomb's law is only applicable for the point charges. What are the point charges? Here, the mass is negligible. And remember, if the two charges we are taking, the other charges are near to the two charges. Means there will be no impact on the other charges. Means in the Coulomb's law, it will be two charges we are keeping Q1 and Q2. The other charges are present near the Q1 and Q2. There will be no impact on the other two charges. The assumption of the Coulomb's law. And in addition to this one, the other thing about the Coulomb's law is that it will be applicable only up to 10 to power minus 13 meter. Less than the 10 to power minus 13 meter, it is not applicable. Why? Because there will be predominance of the nuclear force. That means what? Already the nuclear force is existed below the or the less than the 10 to power minus 13 meter. That's why the Coulomb's law is only applicable for the up to the length of the 10 to power minus 13 meter. And the other application of the Coulomb's law we will discuss in the later classes. Now we will discuss about the electric field intensity. And remember one thing, the value of the epsilon naught is 8.85419 into 10 to power minus 12 Coulomb square by Newton meter square, and dimension of epsilon naught is m minus 1 l minus 3 t4 a2. Remember, the value of epsilon naught is 8.85419 into 10 to the power minus 12 Coulomb square by Newton meter square. The dimension of epsilon naught is m minus 1 l minus 3 t4 a2. Now we shall discuss about the electric field intensity. What is electric field intensity? See, before discussing about the electric field intensity, first we shall have to know what is electric field. See, for further going to the electric field, let us take the example of gravitational field. In the case of gravitational field, if an object is there, it will not impact directly the another object, or it will not impact the gravitational force on the other object. How it will impact? If you take an object, let's take this is an object which has a space around which the gravitational force will impact on it, or the gravitational force will be experienced. If you take another object, outside the gravitational force, it does not impact directly the gravitational force which is not present within the gravitational field of that object. Whenever this object comes within the gravitational field of that object, then only it will interact with the object. That means what? It will apply the gravitational force on that object. Similarly, if you take the example of charger body or a charger. In the case of a charger, if you take a charge, the space around the charge, there will be some electric field, and this field will be experienced by this charge only. Whenever any other charge will be within that space, then it will interact with another charge particle. As these two charges are interact with each other, they will apply or they will interact in the electric field of attraction or repulsion. And remember, if this charge particle will displace to the another place, to propagate its electric field, it requires some time. That time t is equal to r by c, where r is the distance through which it was displaced, and c is the velocity of light in free space. Now we can define the electric field intensity in such a way: the force required to move the charge to a point, the force required to move a charge to a particular point per unit charge. That means what? To move this charge to this position, there should be some forces required. As we know, whenever we are moving charges, there will be no single charge we are moving. We are moving some bunch of charges, and per each charge, how much of force is required, that is called the electric field intensity. Or simply we can say that E vector equal to F vector by Q. This F is the the force required to move the charge, and this Q is the test charge. As it is, this charge is moving, and this charge is the for use for the testing the electric field intensity. That's why it is called the test charge, and it is a vector quantity. Okay. With this, today we shall close the topic, and the next discussion we will continue in the next video. I would like to request you all again go through all the topics which we are discussing, and take some notes. In addition to this, I will request you to stay home, stay safe, and learn more. Thank you all of you.